Welcome to Unit 6, Lesson 2, Products and Quotients of Functions. In the last lesson, we looked at adding and subtracting functions from each other, and in this lesson, we're going to look at multiplying and dividing fractions. So you've had a bit of practice with this already. We've worked with the distributive property and the FOIL method for multiplying, and in the whole last unit, you worked on dividing functions with each other. So you should be fairly familiar with what we're doing here already. You just need to learn a few tricks to get through this lesson. So there's some hints down here. It says the domain of a product of functions is the domain common to the original functions. So you want to just see what values they share, just like in the adding and subtracting examples from yesterday. However, the domain of a quotient function must take into consideration that division by zero is undefined. So this is where you get that situation where you might get asymptotes in your graph and in your function, and you just need to be conscious of all those skills that you learned in the previous unit. So the domain of a quotient, h of x, is equal to f of x over g of x, is further restricted for values where x of x, where g of x equals 0. So just be conscious that the bottom of the fraction cannot equal 0 because you do have an undefined point in your graph there. We have this example, f of x is equal to root x minus 1, and g of x is equal to x minus 2. So the domain of f of x is greater than or equal to 1. You can see f of x here. And the domain of g of x is just a straight line. Now, the domain of h of x, it's going to be restricted by that domain of f of x. They are related to each other, so you are not going to have any values of x less than positive 1. So you kind of have that minimum value here going off into positive infinity. Now, when we look at f over g of x, so f of x divided by g of x, we have some restrictions in the domain, which is x is greater than or equal to 1. That's true from the previous example where f of x has that restriction. But now you need to also consider the bottom of the fraction, x minus 2. So what would make this term 0 is if x equaled positive 2. And that's where we get that situation where we have that vertical asymptote at x equals 2. All other values of x are valid for that equation. The next part, determine the product of functions. So if you're given f of x and g of x, all you're going to do is multiply them together. You just need to remember some of your rules for BEDMAS or order of operations, and then at the end combine like terms. So if we have h of x is equal to f times g of x, f of x times g of x. Wherever you have f of x, you just fill that formula in, x plus 2 squared minus 5, and then g of x is 3x minus 4. This term in the brackets here, of course, it will expand to x plus 2 times x plus 2 and use the FOIL method. And then at the end, you're going to subtract the 5 from whatever coefficient is produced. I guess you would get x squared plus 4x plus 4 minus 5. To give you this next step here, and then times 3x minus 4. So to multiply this bracket by this bracket, you need to multiply each term in this bracket by each one in this one. So you have x squared times 3x, x squared times minus 4, 4x times 3x, 4x times minus 4, and then negative 1 times 3x, negative 1 times negative 4. Once you get to this point here, you just combine all the like terms. So write it from biggest exponent down to smallest, and then combine any similar terms that are available. If you're asked to find the domain and range, it's very simple. You just look at the domain of each of these functions. Now, f of x is a parabola, so we know that it has a domain, x is an element of the real numbers, and g of x is also a straight line, so it also exists as all real numbers. Therefore, the domain of h of x will just have x is an element of the reals or negative infinity to positive infinity as well. The range of course, is also y is an element of the reals, because if you remember, for that cubed shape, we have something that looks like this for the shape of our graph. So it just continues off in both directions. For determining the quotient of the functions, I think maybe it didn't come through great on your photocopy. So the value here, I'll try and clean it up with my pen. It's 2x plus 6. And then on the bottom, you have x squared plus x minus 6. Okay. So this is something that we have done in the previous unit. All you're doing is going g of x divided by f of x. Make sure you follow what the letters say here and put the things in the right place. So here, g of x is 2x plus 6. It goes on top, divided by f of x, x squared plus x minus 6. Now your first step here is to factor that quadratic equation. So we can break this down into x plus 3, x minus 2. Now that we've done that, we can see that we have x plus 3 on both the top and bottom. If you remember, that's a non-permissible value. So x cannot equal negative 3. And that would create a hole in your graph at that point. Now, the other spot where x is not allowed to be, because it would create a 0 in the bottom of the graph, is positive 2, because you have x minus 2 here. 2 minus 2 is 0. So you'll have a vertical asymptote at x equals 2 and a hole in the graph at x equals negative 3, and then whatever the corresponding coordinate is for that. So at the end of it, once we've simplified, we can say h of x is equal to 2 over x minus 2, and x cannot equal negative 3 or positive 2. Once you've done that and figured out the formula for the equations, you can sketch the graph of each of those on the same plane. So just like we talked about in the other page, we have that vertical asymptote at x equals 2, and then all three of our graphs are on here displayed for you: f of x, g of x, and h of x. The domain and range, there's a bit of an explanation here. So the quadratic function, the parabola, it has an domain of x is an element of the reals. G of x is also a straight line, so it also has a negative infinity to positive infinity domain. Now for h of x, it consists of all values that are in both the domain of f of x and the domain of g of x, excluding values of x where f of x equals 0. So remember, f of x is on the bottom of the function here, and we can't divide by 0 because it creates that undefined value. And that creates our vertical asymptote that you see up on the graph here at x equals 2. Now, that point of non-permissible value, which we talked about on the last page, negative 3, if you plug negative 3 into your function, you're going to get a y value of negative 2/5. So at that point, negative 3, negative 2/5, it's kind of right there on your graph. It's squished between the crossing of those two graphs, but there is a hole there. And we also can't have it defined at x equals 2. So therefore, the domain of h of x is all values except for negative 3 and positive 2. If you're unsure, you can always draw one of these number line charts to help you determine what the range and domain will look like. So you can see here the domain of the parabola f of x goes from negative to positive infinity. The same for our straight line g of x, negative to positive infinity. And the domain of h of x, it has those holes, one at negative 3 and one at positive 2 with the vertical asymptote. The range, of course, y cannot equal 0. You have a horizontal asymptote here, the x-axis. And then also it cannot equal negative 2/5 where that non-permissible value is. All other values of y are valid. Beyond this, you have some practice questions, and then you can continue on to the homework for this lesson.